Wood is a natural, renewable and sustainable building material with a smaller carbon footprint than steel or concrete. Maximizing wood use in both residential and commercial construction could remove an estimated 21 million tons of carbon dioxide from the atmosphere annually, equal to taking 4.4 million cars off the road. Softwoods like pine take less time to grow than hardwoods like oak, so they are a more sustainable option. However, untreated softwood is susceptible to rot and mold, so it is typically not used outdoors. Well, that's about to change. In this video, we're going to understand how ancient Japanese techniques modified the components of wood to make them stronger and more resistant to decay. Wood fibers are composed of several layers called cell walls. The three main components of a wood cell wall are similar to those of a CMU block wall. Cellulose is like a concrete block. It is an important structural component. Hemicellulose is like the mortar. It is a supportive matrix that strengthens the cell wall. Lignin is like rebar. It is a mechanical support that provides resistance to stresses. Moisture is responsible for the expansion and contraction of wood. It exists in two forms, free and bound water. Free water and vapor are found in cell cavities, voids, or lumens in wood. It contains dissolved minerals, nutrients, and sugars. It enters and exits the wood depending on temperature, humidity, and environment. Bound water molecules are held within the cell walls. They combine with the hydroxyl groups in the cellulose to cause wood rot, decay, and fungus. Wood does not shrink until after bound water leaves the cell. Yakisugi is an ancient Japanese architectural technique that was used to preserve Japanese cedar or sugi wood. It was invented in the 1700s when the durability of homes in remote areas became a major concern. 3 wood planks were tied together lengthwise with string to form a triangular tunnel. Tinder was stuffed into the center of the tunnel and lit on fire. When flames poured out of the top and all the interior surfaces were scorched, the flame was put out with water. This process removes both free and bound water inside the wood. The flames and high temperatures also decompose the cellulose, hemicellulose, and lignin in the wood. The process of slightly charring the surface of the wood without burning the whole piece is called carbonization. It neutralizes the cellulose or carbohydrates in the wood, which is a source of food. This makes it undesirable to termites, fungus, bacteria, and pests. It is also waterproof, fire retardant, and resistant to rot. It can last over 100 years with no intervention. Unfortunately, this method was almost forgotten when cheaper wood alternatives flooded the international market. In the 1990s, the VTT Technical Research Center of Finland developed a new method of preserving wood based on the Yakisugi method. They called it thermally modified wood or Thermowood. It is produced by a 3-stage kiln process that only uses heat and steam. In phase 1, carefully selected dried wood with a moisture content of 12% is placed in a kiln. It is heated to 100 degrees to 150 degrees Celsius for 48 hours. The moisture content of the wood is reduced to nearly zero. The sap and pitch are also cooked out. In phase 2, the temperature of the kiln is rapidly increased to 180 to 240 degrees Celsius and plateaus for 4 hours. This high heat and lack of oxygen causes hydrolysis. This is the breaking up of hydroxyl groups in the hemicellulose of the wood. The planks start to darken as the wood cell components degrade. In phase 3, the temperature inside the kiln is decreased and steam is pumped in. This helps cool the wood and increase the moisture content of the planks to improve stability. The average moisture after this phase is 4 to 5%. After the wood planks are removed from the kiln, they are milled down to consistent sizes with tongue and groove joints. Arborwood, a Minnesota-based company, sent me these samples of thermally modified wood for an unpaid, unbiased review. This product has plenty of advantages. It is one of the most natural ways to extend the life of wood products. It is also free of chemicals, so it's a more sustainable option than traditionally treated lumber. The wood is gorgeous. It has a consistent dark appearance throughout, not just on the surface. It looks like caramelized sugar. Because the number of hydroxyl groups in the cells are decreased, it is water repellent. It is also fire resistant. It is dimensionally stable, it doesn't expand or contract much, and it doesn't warp or cup. Because the sugars are affected in the kiln, the wood is not a food source and is resistant to rot and mold. It is lightweight because of its low moisture content. In fact, it is significantly lighter than the greenish pressure-treated outdoor lumber. It is maintenance-free. It has a longer lifespan of 20 to 30 years. We can also use cheap, rapidly renewable pine wood to make long-lasting, outdoor-rated products. We can use domestic wood instead of hardwoods sourced from the Amazon rainforest. We can even use beetle-infested pine that might have to be thrown away. You can find a wide variety of finishes from traditional ash to burned and brushed to a whitewashed finish. Thermally modified wood can be used for outdoor decks, siding, interior flooring, millwork, windows, doors, saunas, and outdoor furniture. It is also used to make bridges and necks for guitars since it doesn't warp and always keeps the instrument in tune. Now the disadvantages of Thermowood. Thermal degradation and lower moisture content makes it brittle. It is more expensive than untreated softwood, but around the same price as hardwoods, at least before the blip in lumber prices. It is not structurally sound and cannot come into contact with the ground. Oil, stains, and water-based finishes don't work on Thermowood because it is hydrophobic. Some adhesives that rely on soaking into the wood fibers to bond may also not work. Because the wood goes through so much stress in the kiln, you must use premium grade lumber planks without large knots. The wood shrinks about 5 to 10%, but most of the wood lost is from milling and machining. The wood is not UV stable. The color changes to a soft gray over time. If you want to maintain the brown tone, you have to use pigmented top coats. Arborwood has a product that uses the Yakisugi burning technique on top of a piece of Thermowood. The result is a beautiful charred black top surface with visible grain. It is much more aesthetically pleasing than a black stain. The idea of using sustainably harvested softwood for outdoor applications is very exciting, especially for things like siding. The energy consumed while heating the wood in kilns is a little bit of a concern, but you have to take the longer lifespan into consideration. It also doesn't use any harmful chemicals. Arborwood is building a facility in Minnesota that will capture all the heat emitted from their kilns and use it to heat their buildings, which will create a closed loop. Let me know what you think about this product in the comments below. I'll link my Patreon page in the description. If you can support me, I'd really appreciate it. A big thank you to everyone already supporting me. Don't forget to hit the like button and subscribe to my channel. Thanks for watching. See ya.